Hello, my name is Jadip Sai and I am from Computer Science and Engineering B section. And the topic which I have selected for this TikTok video is shuttle sort algorithm. Shuttle sort. There is a simple sorting algorithm which is called shuttle sort. This is also known as bidirectional bubble sort or the cocktail shaker sort. These alternate names tell us that the shuttle sort isn't about the space shuttle. It's about something that moves back and forth. Now, how can think of that when you think of this algorithm? What's the essence of the algorithm? The essence of the algorithm is that we iterated from left to right, swapping elements and checking whether any of the elements remain in the other direction need to be swapped. So we have a simple sorting algorithm which is called as shuttle sort. This sorting algorithm is also called as bidirectional bubble sort and also it is called as cocktail shaker sort. So it is similar to the bubble sorting algorithm. These alternate names tell us that shuttle sort isn't about the space shuttle. So the word shuttle sort is not related to the space shuttle. It is related to the moving of the back and forth elements of an array. It is This simple sorting algorithm is used to arrange the data in either ascending or descending order. The essence of the algorithm is that we can iterate from left to right. So in the sorting algorithm, we iterate the elements from left to right, swapping the elements and checking whether any of the elements remain in the other direction need to be swapped. So we iterate the elements from left to right and check if the elements are not arranged in proper order. So if the elements are not arranged in proper order, then we are going to swap the elements and we are arranging in either ascending or descending order according to the requirement. So it is all about the shuttle sort algorithm. It tries to mitigate a defect of the bubble sort. So it tries to solve the defect of the bubble sort, the problem of the rabbit and turtles. It's a situation when a heavy bubble is placed at the end of the array, while the light bubble rabbit are ascending rapidly. The heavy bubbles turtle descend only one position each per iteration. So this shuttle sort algorithm is similar to the bubble sort algorithm. It tries to mitigate the defect of the bubble sort. So it tries to rectify the problems of the bubble sort, the problem of the rabbits and turtles. So we have a situation when a heavy bubble is placed at the end of the array. So where the which has the highest value is placed at the end of the array, while the lightest bubble, which is a very less value, are ascending rapidly. The heavy bubbles turtle descend only one position per each iteration. This algorithm will speed up the turtles by changing direction at each iteration. So this algorithm will speed up the turtles by changing direction at each iteration. So with each change of the direction, the rabbits becomes turtles and vice versa. So we are swapping all the elements by using this shuttle sort algorithm. The heavy elements, for example, they are of high value, are placed towards left, and the low value elements which are already existing in the array are placed towards right. By using this shuttle sort algorithm, it is it not only allows the larger elements to mitigate quickly to end of the list, but also allows the smaller elements to mitigate faster to the beginning. So it not only allows the elements which are of higher value to move towards the end of the array, but also speedens or faster makes the movement of the small values faster to arrange them in a proper manner. So this is about the shuttle sort algorithm. Coming to the time complexity and the space complexity, The shuttle sort does not add much to the bubble sort. So it also follows the same time complexity and space complexity as of the bubble sort. In the worst case, with the data sorted in reverse, the successive runs of the table requires n2 minus n by 2 each exchanges. For example, for a list of 10 items, it will take 45 comparisons and 45 exchanges. The time complexity is therefore quadratic of the order of big O of n square. So in this, the time complexity, the worst case is when we have to reverse all the elements. So it is a very complex task and which requires more time complexity. And that value is big O of n square. When the initial order of the items to be sorted is random. So when the elements are in the random in the array, it is considered that the n square minus 2 into n by 4 exchanges will be needed. So the complexity will therefore also be big of n square. So both have the big of n square values in the time complexity. If the elements, all the elements are to be arranged in the reverse order, where the last elements are comes to the first and first elements are moved towards the last of the array. So at the time complexity of the shuttle sort algorithm may be big of n square. And in another situation where the element all the elements are in the random, then also the time complexity is same, that is big of n square. So in this time complexity, it is similar to the bubble sort algorithm. Next, the best case. So we are coming across the best case. When the list is already sorted, it will take n minus 1 comparisons and no permutations. The time complexity is linear, that is in big of n. So we have seen about the worst case. Now we are going to see about the best case. In this best case, the all the elements are already in sorted order. So at that time, the time complexity is linear, which is big of n. In terms of space used, the memory cost of the algorithm, the complexity of the shuttle sort is linear. It grows at the same speed as the number of input data, therefore big of n. So coming to the space complexity, the shuttle sort algorithm is linear. It grows at the same speed as the number of input data. So as the number of the input elements increases, then the space complexity of the shuttle sort algorithm also increases. So in terms of the space used, memory cost of the algorithm, the space complexity of the shuttle sort is linear. So the complexity of the shuttle sort is linear, which I have already told. It grows at the same speed as the number of input data. So as the number of the elements are increasing in the array, then the space complexity of the shuttle sort algorithm also increases, which is big of n. In shuttle sort technique, for n elements in an array A, it requires n minus 1 passes. So in this shuttle sort algorithm for n elements, we have using n minus 1 passes. With ith pass, where 1 less than or equal to I less than or equal to n begins, the first I elements, that is elements a of 0 to a of I minus 1, have been sorted, and these occupy the first I positions of the array. To insert I plus 1th element, a of I is compared with the a of I minus 1, and if the value of a of I is smaller than a of I minus 1, then they are exchanged. In the same way, the process continues until either no exchange is required or the beginning of the array is reached. The time complexity of the algorithm is big of n square. So in this shuttle algorithm technique for n elements in an array A, it requires n minus 1 passes. So for the n elements, we require n minus 1 passes. When ith pass begins, the first ith element, that is element a of 0 to a of I minus 1, have been sorted, and this occupies the space I, the first ith position of the array. To insert I plus 1 the element a of I is compared with a of I minus 1. And if the value of a of I is smaller than a of I minus 1, then they are exchanged. So if the value of a of I is less than a of I minus 1, then the elements are swapped, that is, they are exchanged. In the same way, the process continues until the either no exchange is required or beginning of the array is reached. So we are iterating the elements of the array from I. So in that we have, if if in the condition, if we have a of I less than greater than, if we have a of I less than a of I minus 1, then we are going to swap those elements, and we are continuing this approach until the or either the all the elements are got swapped or the beginning of the array is reached. The time complexity of this algorithm is big of n square. Let's see how the code of the shuttle sort algorithm works. So we have come with a C program in which we are going to use the shuttle sort algorithm. In that we have used hash include stdio.h. It is a header file for inputting the values, and we have functions input and output functions in that. And we have also used the hash include stdlibrary.h, and we have created a function shuttle sort with the return type void, which has the parameters, which has two parameters. One is for the inputting the array, and another one is for the length of the array. So the array is denoted in the shuttle sort function is by a variable a, and the size is denoted by n. And we have declared two variables I comma j, where I is initially given value as 1. So we have also created a variable by name temp. So we have declared the temp variable with the data type as integer. So we have created a while loop with the while condition. The condition given is I less than n. So we have created a while loop by giving the condition I less than n, and in the body of the while loop we have created another while loop. Before that another while loop we have assigned the value of the j as j equal to I minus 1, and after that we have created another while loop in which we have given the condition for the while loop to execute it, that is j greater than or equal to 0. So if the j is greater than or equal to 0, the while loop, the inner while loop will be executed. If the j is less than 0, then the while loop terminates and comes again back to the external while loop. So the in this internal while loop with the condition j greater than or equal to 0, in that while loop we have created if statements, and in this if statement we have given a condition which is a of j greater than a of j plus 1. So in this we are checking for if the first element of the array is greater than or greater than the second element of the array, then we are going to swap those elements. So in this if condition we have given a of j greater than a of j plus 1. If this condition satisfies, then we are assigning the temporary variable value to the a of j, and we are giving the value of a of j as a of j plus 1. And again, we are giving the a of j plus 1 value to the temp. So thereafter, we are decrementing the j value. So in this condition, if in this if condition, we are checking whether the first element is greater than the second element of the array. If this condition satisfies, then we have to swap the both elements. We cannot directly swap both elements in the C program. So for that, we have to make a temporary variable which is denoted by the name temp in our program. So temp will store the value of the first element, that is a of j, and the a of j value, that is first element variable, is stored with the second element. So that is we are assigned by using a of j equal to a of j plus 1. Then afterwards, now the a of j plus 1 should get the value of the first element. So we are assigning it with the temp, which stores the value of the first element. Then afterwards, we are decrementing the j1. So this loop executes, and if the this condition didn't satisfy, then we are breaking the loop. And then afterwards, we are incrementing the I variable with I plus plus. And printf, we are using printf backslash n to make all the values, the next values to printed in the new line. So thereafter, the sorted array elements are given below. For I equal to 0, I less than n, I plus plus, we are going to print the value of the array elements. So it is the main function of the shuttle sort algorithm. In this, we are initializing a variable I and n. We are given the data type as integer type of the I variable, and also for the n we have assigned the value is 6 and with the data type as integer. Now integer of a of I. So we have created an array of the type integer with the values 15, 8, 17, 12, 38, and 19. We didn't mention the size of the array. By default, it will take the value as 6 for the size of the array. So we are printing shuttle sort. In another print function, we are printing input array elements. So we have used a for loop in which we have I equal to 0 is the starting point of the I variable, and we have given the condition where I less than n. So till the I is less than n, we have to increment the I value by using I plus plus. So this for loop is going to be executed. In this for loop, we have given a print function where a of percentage d equal to percent d, where first percentile d is I and next percentile d is a of I. So the all the elements of the array are going to be printed, and we are performing the shuttle sort to the given array. So we have called the shuttle sort function by using the array and size of the array. So this program gets executed when we run the program, and the output for the after giving the all the values, the shuttle sort algorithm works. So the first one, it will print the shuttle sort, then the input array elements will be printed. So these are the elements which are printed as we have declared the array. These are the elements. These are the elements which we have defined in our array in the main function. These are the elements. So these are the elements before swap. So we can see here 15 is greater than 8 and 8 is less than 17, and these all the elements are unordered. So to make these elements ordered, we have called our shuttle sort function, in which we have passed the array and also the size of the array. After the shuttle sort algorithm is called, the shuttle sort will do the operations which we have given, which it will go to the first while loop, and it will iterate the I value, and in that I value we have created another variable j which is I minus 1. So in that I minus 1 we have given another while loop in which if the j is greater than or equal to I, In that time, we have to increment the j value, and we have to check the first and second elements of the j. That is a of, we have given a if condition where if a of j is greater than a of j plus 1. So first element is greater than second element, so we have to swap. So for the swapping, we have created a temporary variable. So the temporary variable will store the first element, and the first element is assigned with the value of the second element. Then again the second element is assigned the value of temporary variable. So in this way, we are going to swap the elements, and we are decrementing the j variable so that the loop terminates, by which the shuttle sort algorithm works. And at last, we are printing the elements, the array, all the proper ordered elements. So in this way, we are sorting the elements by using the shuttle sort algorithm. I thank the faculty and the college for providing me this opportunity to speak on the topic. Thank you.